Hey, Provost, what's up, man? Hack the planet. Oh man, sitting here chilling. It's like, is it time to start yet? Hack the planet. And I hadn't even started the dang timer yet. All right, hang on. We're gonna fast forward this a little bit. There we go. Yep. There we go. That's right. All about that hack the planet life. Hey, Gumby, thank you for those 9 popped shells. What's up, brother?
Bullshit, I can't hear you. Sound off like you got a pair.
And thank you for the early troll. You know I love you, boo. Oh, Gumby, that sucks, man. I'm not looking forward to that day. So I know I said that I'm not going to use Windows 11 as a daily driver. However, it will have to be on the streaming computer because trying to run OBS on anything else kind of sucks. Let's go ahead and kick off the stream here. What's up, everybody? I hope y'all are having an absolutely superb Sunday. I had a really good day today, man. We took the kids out to a new motocross track, and for reference, a lot of the motocross tracks, at least in our area, don't allow ATVs. They're strictly dirt bike, and because they feel like the ATVs tear up the track. Which, yeah, if some guys are jerks, they can do that. That's not usually how it works for us. We have a pretty good crew that understands and wants to take care of the tracks because we want to go back out there and we want to keep ripping it up. I was not ripping it up today, but my son, two of my nephews, a whole slew of our friends were out there, and they were just getting after it on that track. It was our first time out there. The guy, he's got kids himself, the guy who owns the track, and so he graded it well for it to work for the kids, but also the way he set up the jumps is you can either just kind of roll them, like if you're one of the young kids, or you can hit that sucker, and man, some of the adults were getting some serious air. The kids, a little bit. They're still feeling out the air, but some of the more seasoned adults, guys who are in their 60s that have been riding motocross for like 40 years, getting out there and just boosh, full send on it. They were kicking butt. It was nice. All right, I'm checking out. Unfortunately, I did not remember to send the question to the LangGraph guys about this recursion limit issue. So I think actually we might be able to work through this problem just a wee bit. Just a wee little bit here. So let me do something. I'm going to actually kill the server real quick. It's not bad running OBS on Arch, really? And I do have an AMD on this system. There's other stuff that I do need to run in Windows, but I could always, a lot of them aren't graphically intensive. Except my video games. But I have another idea for that. The problem is the usual problem, money. So I was like, oh yeah, I could come up with a really killer solution for that if money was no object. Let me check something real quick. So which is this? That's one of our bin files. So what I'm doing is I'm looking at the LangGraph server. Oops, I screwed that up. Let's see what the file is for this. Because I believe that's just a Python script. Yeah. So what I want to do is... yeah, I'm just going to Vim it real fast. I'm going to go take a look at it. Of course, that's what it is. It's not doing anything, yo. It's just a wrapper. Let me exit out of that. What I'm trying to find is the LangGraph server code. So I want to go look at what it's doing. Because in theory here, right, we run this inside the HackBot directory. We have our LangGraph JSON somewhere in here. Wait, did I delete it out? I think I did delete it out because it wasn't doing what I thought it should. Because I was looking at this documentation just before we hopped on. So this is for the LangGraph server structure. At least this is the theory behind it anyway. So there's our requirements, env, our agent, and directory structure could change. That's fine. Because this is talking about it as if you're executing it directly. However, so what I'm going to do is, because I don't trust this documentation fully, actually, hold on, let me look at this dependencies here. Same thing on the gaming side, that's why I haven't fully switched over to Linux. And some of my chasing software is only for Windows. Yeah. And that's, so what I actually had thought about doing was having a dedicated Windows machine that I would basically just remote desktop over to from whatever my primary system was. That was kind of my thought behind it. All right, so the LangGraph server, for some reason, wasn't recognizing this LangGraph JSON here. Where is this? This should just be in HackBot, yeah. LangGraph.json, which according to this, that should be the default configuration file that it uses. Yeah, LangGraph.json. Now, unless this config isn't where I want it to be. So, one thing I thought of doing is let's go dig into the server code. Let's go find it. Let's see. Python, GitHub. Because let's just go RTFC this. We can go read the code and we can figure it out. Dr. Reiki, what's up, brother? How you doing? All right, let's go find this. That's not it. I know that's not it. Well, we should be able to go find it in their org. I don't think this is... Maybe it's the LangGraph CLI. Is that the actual term I think I need? Let's see. LangGraph CLI. Yeah, I think this is the one that I actually need. Yep, this is the one we need. Okay, so LangGraph CLI, what we need is, let's go... That's not what I want. Where's the repo? Here we go. Oh, so the CLI is part of this repo. Got it. So hold on one second. Let me do something real quick. Let me, rather than vimming that, let's just cat it real fast. All right, so the LangGraph one is executing in our Python virtual environment, import sys, and then from the LangGraph CLI imports that. And that's it. It just runs whatever we got here. So it runs that script. Okay. So what I need to find is, this is like the entire thing. I guess they've got the CLI kind of rolled into this. Let me see if I can find it. Because what I want to see is, what we've got in the project is we have the LangGraph stuff all specified in here. Where is our studio config? We have LangGraph studio.json. Our dependencies are just here. Oh, this must be the config it's talking about. And so we do have our env file, but one thing I want to check is, can we change the graph recursion limit in the env file? So I'm trying to figure out where it loads that up. Actually, let's just try that. I'm not spelling recursion right, am I? I'm not. Actually, there it is. That's the one we need. Let's go find this sucker real fast. So where do we see this actually? There we go. Perfect. This is what I was looking for. This one line of code. Excellent. Because according to this, damn it, where'd you go? There it is. So for the internal config, the recursion limit should be get env file LangGraph default recursion limit, and it's set to, otherwise defaults to 25. So if in our env file, if we set this, we should be able to buff up that recursion limit. Unfortunately, that means I got to drop into OPSEC mode real fast so I can go edit the env file, and all you little trolls, do not burn up my API keys like last time. Nah, I'm just kidding. You almost tried. It was at the end of the stream and I revoked the API key. Let's see. Where's my env file? So we're going to set that to 50. Okay, so what I did is I went and I set that in the env file. Now let's go run the server and we're going to see what happens. Oh, damn it. I forgot. I need to boot up the Try Hack Me box. Let's get this guy going here. If it'll load, I mean, if not, that's cool. All right, so it should be on there. There we go. I should have started this up before the stream, but I was actually trying to get for some reason the iPad isn't working today. So unfortunately, no fun diagrams. Hack the planet! If only I were smart enough to API key like a ninja on the stream. So actually, what's funny is you notice how you don't see the address bar up here, right? So see, this is the actual like top of the browser. I cut that off because during the time when I began streaming, I showed the entire browser. However, what was happening is there was a particular system we were accessing, and the access key was in the URL. So someone screen capped it, OCR'd it, and was able to boot me off of the session. And so we're like, okay, lesson learned there. And it was an Apache guacamole system, and that's what it does, is it uses that up in the address bar. So instead, we just had to like, okay, lesson learned. We're gonna hide the address bar now. Yeah, it was pretty funny, man. All right, cool. We got the new IP address. Let's go get our demo data from Stinger. And let's run this baby. I'm going to drop you right there. That is not the correct IP address. Come on. There we go. All right, let's get our seed data here. And then this will seed us up for the rest of the night. Plus, for some reason now, all of a sudden, the port forward is working. So, yay. The one that wasn't working last night. Hold on, this is in the exploit graph. Let's go back to Stinger. We need to run this in Stinger. There we go. All right, we'll let it do a full run here. Yeah, it was pretty funny, Gumby. He was actually pretty cool about it, and so he explained what was happening, and I thought that was the case too. But, whatever, it was a learning experience. All the rules are written in blood, right? All right, so it's going through, it's doing some recon. We'll have to just sit tight for about 2 minutes while it runs through the recon and enumeration. And then I'm expecting it to hit the exploit agent and probably crap out again. In one of two ways. Either it's going to hit a new error that we haven't seen, or it's going to hit the recursion limit, and we know that the env file doesn't in fact work. So, either way, we'll be good. I'm glad you're able to be so calm about it, because that kind of sounds like an attack. No, he was in the stream, and he was chatting, and we were joking about it after he explained it. And so I was like, dang it, I thought that was the case. But I didn't think anybody maybe would go through all the trouble of either typing out, because it was a very long pseudo-random string. And I was like, no, either somebody's going to not take the time to do that, or OCR it or something. Well, someone did. So I was like, okay, well, the attack has been proven. Let's nix that information disclosure there. Let's close that gap. All right, let's go check the trace on this real fast. All right, Stinger is running, doing his job. So we're already down in the enumeration agent. It's running GoBuster. Good. So we only have to run this the one time. Oh, you know what? I forgot to check something. The VPN should still be on from yesterday. Ooh, let's go double check something real quick. Because I don't know if I need to restart the VPN or not. Let's check the Nmap results. Did GoBuster find anything? Sorry, output. It did find panel and uploads. Okay, perfect. So, GoBuster's working. Excellent. That means the VPN was still functional. Good. Because usually I try to shut it off at the end of the stream, but honestly, I forget a lot of times. I'll tell you what, something that actually really disappointed me was the first video I dropped as I started trying to do these Saturday video releases, which was about Hexstrike. Got like 600 views, and I was like, okay, pretty cool. The one that I thought was actually the better video and was way more impactful and everybody should know about to realize the fragility of our systems, about the Azure authentication bypass that Dirk John found, has only gotten like 50 views. I'm like, this one is so much more important than this just ranting one about Checkpoint's blog that was horribly written about Hexstrike, but didn't have any of the capabilities that they were claiming it did. And I was like, ugh, it's just stupid YouTube. I wish I could swap those numbers. Not get like just more on one. I wish I could literally swap them so more people would see, hey, this is how close we literally came to the entire Azure ecosystem, like, dying. You thought CrowdStrike was a bad thing. This could have caused absolute mayhem. CrowdStrike just shut everything down. Nothing was compromised. This would have actually been a massive leak. It would have made the NPM stuff look like a walk in the park. Let's see. Where are we at now? Wait, the enum agent had an error? That's unusual. What happened here? This is the new one. Response not read. Attempt to access streaming response content without calling read. What? Where did this happen? Oh, something happened in the enum validator. Let's see. That's weird because we didn't even touch the enum validator. But that's so weird. Do I want to just run the whole thing again? I guess so. Let's back it up. Because the recon and enumeration validators should be nearly identical. There shouldn't be any reason why the recon validator would work and the enum validator would not work. Let's see, do I still have it? Yes, I do have it. All right, let's just do another seed run because we need the seed run to get the information to the exploitation agent so we can use it for that. If I was running this locally where like we knew what the target IP was and some other factors initially, we could have just saved the pickle and gone directly to it. However, since I'm using this try hack me box for this first initial pass, what we had to do is wait for it to boot up and then figure out what the new IP address is and then run through the whole shebang. So past Blaise would have been smart to just set up one that was locally hosted that we could have tried to attack. But you know what? Hindsight's always 20/20. All right, we'll let this run its thing again. I need to figure out a better way to parse the in-map output. Because right now, we send everything over to... Right now, we send everything basically to the language model. So when recon happens and we hit in-map, right? What happens is we go to an output formatter node. And this is a lot of data in here. Because we're using the XML and it just spits out a ton of data. Now, the reason why we're using the XML is because it gives us this CPE variable right here. And for some reason, Nmap in their infinite wisdom only outputs the CPE value, which could be handy later. It's pretty much just there for a little bit of future proofing. It only spits that out in the XML format, which is kind of rude. So then it goes to a recon formatter, which is basically the same as the enumeration formatter. But anyway, we send it a very simple system prompt with two options. It can either format Nmap output or any other standard output format. There's only two output formatters. So what it does is it comes through and it kind of parses that information for us and builds it into this output form. And then it gets appended to the host table. So then we've got a tracking for all of the hosts that we find. But I don't get why it was doing that. Let's see how far we are with the new run. Okay, GoBuster worked. Validator worked. Looks like it validated it. So we had our question, answer, and our reason. Good. Good. And so that means we should be over in the exploitation agent now. Oh no, there's one more task for enum. I forgot about that. It's to browse to it, and it typically uses the Katana headless browser when it does that. Yeah, there it is. The headless crawler. Which is kind of dumb because the headless crawler won't actually get that there. because you can't get to the reason why we had to do GoBusters because the panel and the uploads directory are not linked anywhere else. Crawlers go through and they look for links from a page, either like anchor links in the HTML, or I don't know if Katana will actually parse out the JSON or not JSON, the JavaScript to look for links to other systems. I think it will, and so it's a crawler, but you can't crawl to those other two directories. But it doesn't matter. It's no big. In fact, we can actually see what Katana's doing. We come back over here, and then we go to the RoboPages server. Why did it build the in-map image? It shouldn't have had to build anything. I need to double check something real quick here, because I think we got a bunch of browsers up here. Yeah, we do. We gotta stop all those browsers. Let's kill these. Ah, dang it. When I copied it, I forgot to put a space in it. Lame. Alright, let's kill... I want to kill all these before it spawns the new browser. Actually, it shouldn't matter because the new browser is not going to be in this list. There we go. There you go. See, this one's been up for 25 seconds, so we're good there. Yep. I should have spaced out more, Gumby. Hey! Alright, let's see where we're at here. We should be down in the exploitation agent. I don't know if this is where how they intended this to run like this with this much data. I wonder if I'm inadvertently stress testing the LangGraph Studio. Alright. Not sponsored by Jocko yet. I finished that one early because I'm probably still dehydrated from being out the track. We were out there from 9 o'clock until like 3 o'clock. And it wasn't an obnoxiously hot day, but it was still pretty warm. And I was keeping track of the kids. I'm a little sunburned. Arms will be nice and toasted when we get done. Alright, cool. We got through the exploit agent and we got an error. So let's go see if we got the recursion error, because that's going to be the main kicker here. Actually, this is not bad. We hit a rate limit error. A rate limit error is not terrible. So what that means is we were sending too much data in too short of a window over to Anthropic. There are way worse issues to come across, but let's see where we got with this. So let's come down to the exploit agent. Where are we at? All right, so it got the web shell artifact. It navigated to the site. It tried to do the file upload, which it should be, if we look right here, it should tell us, hey, this failed. Yep, it failed because it doesn't like the PHP extension. So then let's go check and see what the revisor did. Because remember, we updated the revisor last night, where it can either modify the current task or it can prepend a new, it can modify the current step. I've got to make sure I'm very clear on that. There's an exploit task and there are steps to the task. So it looks at the step and it tries to decide, did it work or did it not work? That's what the validator's job is. If it validated and it worked, then it just says, okay, go on, can start doing the next step. However, here, we made a modification to it where if it has to update it, it can either change that particular step or it can insert a previous step. Like, okay, we need to go rename this file, right? So let's see what it did here. So here's our revisor. We send all the information to it. And then let's go to our output. So basically the output, we attempted to upload a PHP web shell through the file upload form, but received a message that it's not allowed. Indicates the service blocking PHP uploads as a security measure. So the revision was try to bypass PHP extension filter by renaming the shell with a different extension. Now see, this is the kicker though. We need to go work on the prompt a little bit more because this is not an atomic task. It's a compound task. It says, hey, try to rename it and then upload the web shell. So it did do the rename here. Let's see what it renamed it to. So it renamed our shell.php to shell.phtml, which is a valid guess. And then what does the revisor say after we do this? Let's see. It says it was validated. Good. So then what should happen is the step processor should now be working on the next one. Let's see. What's the actual task in here? Upload the web shell. Good. So if we come back here, let's back this thing up a bit. Back it up. Back it up. And if we go look at the exploit steps that happen here, right? So they're down here. So 0 was prepare the web shell. Number 1 was navigate to the panel page. Number 2 was try to bypass the PHP shell. So it inserted. It inserted just right where it's supposed to, and it prepended it. So now it's trying to do a bypass, and then it will come forth and try to do the upload again. So let's see what happens when it tries to do the upload. It's working. Nice. So the prepend task in there, or step, actually worked. Nice. Check this out. Success. Uploaded with the PHTML extension. Okay. So this is where the file has been successfully uploaded. It should now be accessible at, you can't see it because it's behind me. It should be uploads/shell PHTML. Excellent. Excellent. So this is, where was this at? Shut up, baby. I know it. What's up, Frozen? What does that have to do with how much peanut butter you can fit in an elephant's ear with a popsicle stick? My favorite one is, what does that have to do with how many pancakes it takes to sand a doghouse? All right, let's see what happens here. So, part of the problem is, so the overall error that we hit here was we hit a rate limit. Basically saying we're sending too much data to Claude, because that's what we're using as the base agent model. And we're sending basically the raw context from the browser agent. The browser agent is using a React agent. The React agent just basically keeps a list of the messages that were flowing back and forth to Anthropic. The problem with that is they're not refined. They're very raw. So we've got all the data there, but it's really a lot of extraneous data. So I think one of the things we'll have to do, I just want to see it run. I just want to see it upload and find the bypass and get the damn shell. Once that's done, we are going to go take a step back and go refine the browser agent and clean it up a bit. Oh, it's so close. It's trying this. Let me see what file did it try to upload. Did it try to upload the PHTML? It did. Okay. Wait, hold on. Didn't we upload the PHTML here? Did it try to do it twice? Okay, so we got a success that it did upload it. This is weird. For some reason, the revisor, look at that. There's no language model call in the revisor. So how could it have skipped that? Because what should have happened here is all this information should have been sent to the revisor for the revisor to look at all the data that was collected during that step and decide if it succeeded or failed. But look at this. For some reason in the trace, there's no language model call. It should be this icon right here. The step processor came back and is probably trying to do the exact same step again, which is upload the PHP web shell. That's why it called the browser agent again. But it failed during this. Claude spazzed out on us and rate limited us. Oh, you bastard. You bastard. All right, we got to go take another look at this. So let me double check something real fast. So from the exploit step revisor, Okay, so I forgot. We actually have two options here. The revisor can bail out to the exploit agent. So this function here, the exploit step router, that's what we need to go look at. So let's go pull that up real quick. So that should be over in our exploit agent code. All right, so let's go to the declaration for this. All right, so what are we looking at this? So what we do is for the step router, we go check the current step. We get the current task. We pull out the task. We get the oh, this is why. This is why. So what's happening here? I don't know why I put this in here. If true, go to the exploit step processor. Maybe I meant to put a note in here that we're going to hit this later and clean it up. But what's happening here is, for some reason, the exploit step index is not getting set up properly, I bet. Anyway, this shouldn't matter because we should go to the exploit step processor here. But this actually comes after the exploit step revisor. So let's go find the revisor real fast. Where did we do that? There we go. Exploit step revisor. So why would this avoid the language model call? Let's see. So we check here. So here we'd say that it failed. Oh, that's why. That is why. So what happened here, I bet if we go check... Let's go check the state table real fast. I bet that's what's going on here. So let's look at, as we come into the revisor here, let's back this up. And let's go down to the task number 5. And then what we do is we go look at what the current step is. So the current step is 3, which should have been... Actually, it should have been this one here. This one validated. Actually, no, so we are on step 3. So this one was status failed. Yep, look at that. So this one, because it had these previous pieces of information, that's why it failed. And in fact, I bet we have a message in there somewhere that says, hey, by the way, this failed. I don't know if we got the recursion issue finished, Bobby. Also, what's up, man? I just loaded up something. So I read through the LangGraph CLI code real fast, and it looks like when you run the dev server, it actually, somewhere else in the code, we found out that it is actually pulling that from an environment variable. So I went and I put that in the env file. We're trying to figure it out. But what's happening here is it says, looks like the exploit task failed. However, the exploit task couldn't do anything because the way the code is currently set up, even though there's a conditional jump up to the exploit agent, we can't do anything about it. This is a conditional jump in vision only, in view only. It's really just a jump over to here. So that's what's happened here. So basically, we gave it 3 attempts to go after this, but when this happened, what do the actual table look like? Yeah, so we had a call to special agent caller, browser agent, special agent caller, browser agent. Okay. I think what we'll need to do is go take this out of the browser agent. So there's code in the browser agent that inserts into the tool here. We gotta go back and rework this. So when we call the special agent nodes, what we need to do is say special agent caller and then maybe like put browser agent next to it. So we can collapse these down and give it like a chance to just run a couple times. Because yeah, this is 4 elements. Obviously it's bigger than 3, so it bailed out on that. Yep. All right. I was hoping it was an ENV var or something. I was hoping it was too, but I actually forgot to ask the LangGraph guys last night on Slack about it. So rather than trying to mess with it tonight, we're just like, we'll just go RTFC this. We'll just read the code. Oh, I forgot. I turned the camera off because you were behind, because I was in front of the code here. Is the camera working? Camera working? Camera working? Are you sure it's working? I love that little slide animation. It makes me happy. Hey, Monkey, what's up, man? Yeah, I turned it off because there was text behind my big old head right back there. And I forgot to turn it back on. All right, so let's go take a look at this. First thing we need to do is we need to go over to the exploit step, because here's what's happening. That's not the correct one. Here is it. So over here in the exploit step processor is actually where we update this. So there's two parts where we need to update this, which is the exploit step processor, and then over in the browser agent, we'll need to go update that as well. So let's do this part first, and then we'll go update the browser agent. Let's see, where's our exploit step processor? Here we go. So what we need to do is, if the response is special agent caller, then we put the name in here, and then we put in the output, the name. Okay, hold on. Let me double check something real quick, because down in the router, or what are we checking for this? We're checking the number of tool calls in here. Okay. That's fine. So yeah, we'll just have to fix this real quick. This is fine. So we've got the tool right here. We've got the name. So what we'll do is we're just going to format string this. So we'll take it like so. And then we're going to bring this up here. So it's going to look like this. And then we need to do a little bit of curly bracket action. Get some curlies going. Let's see. Another curly. And another curly right there. That should work. Nope, these are off. There we go. Yep, so our first variable is going to be basically the function name and then the agent name, just like that. So we won't append any output in here. Yeah, I think we'll leave it like that. And what I'm going to do is I'm going to comment this out, because then we do want to change the status to working. The rest of this we can leave alone. What we're going to do is now go over, I got to go to my agents.py. Where is that? Actually, I believe that's over here. There it is. So for agents.py, what we need to do is modify this to where we don't modify the tool right here. See, here we add the agent name. Instead, what we want to do is just append the output. So we should just be able to comment this out right here. So now what will happen is we'll have the exploit step processor actually put in the tool, which is the special agent. And then the special agent over here will just append its output right there. Boom. What did I put this to do? It need output logic moved from line 59 to here. Didn't I do that? I think I did. Oh, we'll check it in a minute. Let's see. Let's close that up. Okay, I think that's going to fix part of the recursion issue. Or no, not part of the recursion issue. It's going to fix some of the tracking issue now. So now, cool thing is, we can just run the exploit agent, and we don't have to go through the entire chain again. Yeah. Slide to the left. Slide to the left. Cha-cha real slow. So, funny story, I had an ex-girlfriend that her big thing was going to karaoke. And we'd go out there, and sure enough, the DJ always, once a night, had to play that song. Cha-cha real slow. Always. All right, let's see here. Cool. So we're going through the revisor. me see if I can back out this view a little bit. I wish it wouldn't auto collapse this, because it collapses it as soon as it goes to the next node. It's a classic, I know, right? What's funny is I always did songs like I would always go do Metallica. I had a pretty good James Hetfield impersonation, and then I would do like System of a Down, or what was some of the other ones? I think I did some Linkin Park, but those were always the songs I was doing. And it was funny because there was just nobody else doing anything like that. They were always picking like these top 40 songs. I guess these were top 40, but they weren't picking like, you know, metal. They were picking like pop songs. All right, so we should be down in the browser agent now because we're on the exploit special agent node. Nice. All right, let's see what error we got. It better not be a freaking recursion error. Why does it think it's still running? That's... That's funny, because that was the line we were just on. Did I accidentally screw something up? I don't think so. That's not it. Actually, we just commented out this line right here. Output, agent message. This line didn't even touch anything we were waiting on for that. That's really weird. Actually, from the results of it here, this was saying it was an agent stop behind line 28. Let me go look at line 28 real fast. Which this was our output format. I forgot we had to do this because there was weird issues with this. So for some reason, the dictionary that it returned back didn't have a text field. That's weird. That seems like a little bit of a corner case. Let's just run this again. Take it from the top. Let's see what steps it was actually going through. Where did it die when it did that? Something funky happened. Oh, actually, look at that. It was trying to upload webshell.jpg.php. What the hell? It did rename the file. Renamed it twice for some reason. I bet that's because the step processor probably said do two things or something in here. What the heck happened here? So, did we get a weird set of instructions? Let's go to the planner real quick. So what was our planner? See, it's not supposed to do this because we have an instruction in here telling it, don't do that. Hey, Chris, what's up, man? Thanks for coming online. I hope you are having an absolutely superb, stupendous, super Salabrious. What was, there was a fancy new word someone taught me last night. I don't remember what it was, but I hope that's how your Sunday's going. Salaborious. Salborious? What was that damn word? I don't remember. All right, so this is where it screwed up right here. Save the PHP web shell with the double extension and attempt to basic filter. We literally have an instruction up here in the system prompt that says, provide the minimal list of steps to accomplish the task. Assume the target has no additional security features. So, part of the problem of working with these weird non-deterministic systems, you jerk. Is there anything I can change in that prompt? Let's see. Supercalifragilisticexpialidocious. What's up, Ken? I guess that technically is an S word. Yes. Let's see. I'm going to take this out. I'm going to say it like this. Assume the target has no additional security features. Let's see. Do not include any security bypass instructions. There we go. We're going to fix it up again. We're going to tell it. I don't think for the tokenizer, I'm not sure what tokenizer you're using. But if you don't know this, a lot of times these instructions you send, they get dropped into lowercase, so the capitalization doesn't really matter. But let's go see if this will maybe help it not spaz out on us. So, do it again. We haven't even got the chance to see if the recursion limit was busted. Actually, I think so, because if we look at this, this is pretty long in here. What did we get from this guy? Let's see. Look at that. The .php5 extension worked. What? Hold on. I think we did bypass the recursion limit in here. Hold on. This wasn't the most recent one, though. This is where it failed for some reason. Let me see what this actually came back. And what was this error we got? The actual error was basically saying that the output formatter didn't have a text field to it. The content did not have a text. Okay. Let's see if we get the same error with this one. Come on, babe. It's so freaking close. It is so close. Come on. Come on. You can do it. You can do it, little non-deterministic, hyper-intelligent 4-year-old that can't take instructions. Not true, Gumby. I was able to upload it was successfully able to upload a .phtml5 extension. At least that's what the agent told us. So I bumped up the recursion limit, I think, to 50. So chances are we could still go hit an error with this. All right, so we get an error in the special agent node again. Let's see what the error was. We get the same one. Okay, we hit a rate limit error. Not such a big deal. Although I thought I fixed that rate limit error. Where was that? It was in LLM helpers. Let's see. Yeah, there's our rate limit error right there. So what this does is, we've got this retry wrapper on here, so that if it happens, we should retry it 3 times with a 10-second delay. I'm going to actually back this out to 20 seconds here. Okay, so that kind of resets that. So we'll have like a 1 minute. It'll basically retry this for 1 minute. But also what I want to do is I'd like for it every time it's trying to make the LLM call to do this. Let's just do a quick print statement in here. Print just say making LMLM call. I'm just going to put that in there so that way we can be able to see kind of like where it's happening in here. Okay, let's go try this again. Dude. Come on, little agent. Actually, hold on. Before I get too far ahead of myself, let's see what it actually did here. So what steps did it plan out? So the steps it planned out was create a basic PHP web shell, navigate to the panel, to upload to the upload form, upload the PHP web shell, access the web shell, test executing a command. All right, good. So then it tried to use Python to create the web shell, which was write this to shell.php, wherever that's going to dump it into. I have no idea. So annoying. Let's see. It navigates. It tries the upload. Let's see what happens. So after the upload, seems shell.php is not in the expected location. You're killing me, Smalls. You're killing me. Let me see what else it does here. So after it completely and utterly fails to upload the shell that doesn't exist, what's it going to try again here? Temp shell PHP. And let's see what happens. What ends up happening to it? Apologize for the error. Yeah. Tries another upload. I think we successfully fixed the recursion limit error. See that? Because it kept trying the upload like 4 times in here. Now we're just gonna burn through all the tokens. You piece of crap. So it's supposed to get a shell out of here, Gumby. So it's not supposed to call Python to make the freaking web shell. We have code in there that tells it, hey, by the way, you have an artifact library. And so it should call this function, get PHP web shell Diceco artifact. So Diceco is a particular type of a web shell, particular style, and it should call this, not call freaking Python. Freaking exploit agent. You're basic. You're basic. All right. 3rd time's a charm. Let's go see. Actually, I think this is like the 700th time. Come on. Refresh. There we go. Okay, so it's doing things a little bit different order. Here it says navigate to the panel, create a simple PHP web shell. So hopefully it did the navigate correctly. We should see it actually go pull the web shell from the artifact library. If it will ever refresh. Killing me, Smalls. Killing me. Again, it does the fucking Python exec. Urgh. Making me put money into the swear jar. Because I bet the upload... So it says it created shell.php, but it probably doesn't know where that is. Yeah, temp shell PHP, nothing is there. Okay, you need to stop now. Stop it. Stop it. cancel. So, here. We gotta go fix up the prompt again. There has to be a way to tell it, you will never create an artifact. Actually, hold on. Let's come over to the planner prompt. So let's go back over here. Let's tell it now, never create instructions to create custom I'm hesitant to actually put this in here. Let's see. So what are the directives we have in here? We say all steps should be constructed to be performed by calling tools. Do not include any security bypass techniques. Provide the minimal list of steps to accomplish the task. Assume the target has no additional security features. Do not include any security bypass instructions. All right. I need one more thing in here. It's like, what else could I tell it? Because we needed to stop asking it to create the damn file. Let's see. I don't know what's going on the YouTube side. For some reason, the chat is all jacked up. Seems to be working. So what else can we tell it here? We need to give it an instruction that tells it you should craft this before you should pull it from the artifact library. Let's see. How can we tell this? Let's see. I'm trying to think of the correct word to use. Any code, any remote execution, I'm trying to think of what word the language model is going to use, because essentially what we're trying to figure out is we're trying to anticipate the language it's wanting versus the language it's getting here. Let's see. Let's say, and let's give it a couple examples. So any code such as, let's see, web shells, C2, implants, or binaries should be let's change that. Are to be collected from artifacts I think that's the correct. I'm trying to think of how to phrase this, because what we want it to do is go use the artifact library first before it ever tries to create anything custom. Hey Ivana, what's up, man? Hey, I'm just curious, as part of working in IT in general, do you ever get tired of solving problems? Sometimes, especially whenever usually only whenever it's apparent that the person who brought it to you was capable of solving it and was just too damn lazy. That's the only time it actually gets annoying. Other times would be whenever there's a problem that should have a simple fix that doesn't require a lot of continued ad hoc fixes, you know, basically unnecessary repetition, that gets very tiring. But for the most part, if you're working in IT support or working in blue team or even in red team, there's going to be situations where you're constantly problem solving. So if that gets tiring, that may not be the best use of your time in there. At least not in that kind of, actually, I was going to say in that customer facing capacity, but that's not even true. Because if you're working in any kind of server administration or, you know, system administration, you're going to be solving those problems anyway. New things are going to pop up. We're constantly having things pop up just in this little code sample. And this is just one program, let alone an entire enterprise. So in certain scenarios, yeah, it can get really exhausting. But for the most part, nah, solving problems is fun. It's a fun time. So let's try. Let me read this. So any codes such as web shells, C2 imp or C2 implants. Yeah, let's do that. Are to be collected from artifacts. Let's see. Carlin artifact tools. There we go. We'll put that in there. Maybe that will help it calm itself down a bit. All right, looks like the code's all hot patching in. Let's try this for like the 7,000th time. Doop. I guess you need to approach it with a positive attitude, and then it becomes a lot easier. Yeah, man, because usually I think a lot of people misunderstand IT in certain respects where they think like, hey, I just get to work on computers all the time. No, there's a driver behind that. There's either the business has a need, and your job is to fulfill that need technologically or a portion of that need, or the users have a need, and it's your job to satisfy that need through technology. That's really what IT comes down to. Yeah, you get to work on your cool servers or your cool routers, all those other different systems, but at the end of the day, you're going to be helping somebody. IT is not a profit center. IT is a profit magnifier. So let's say, for example, if you've got a crew of people and they're having to do a very long manual process and it's eating up a lot of time, and that becomes a bottleneck for the business. IT gets engaged, goes through and automates it or finds a cleaner solution to reduce that time and make it simpler, whatever the solution is. And then you can come through and say, hey, look, we saved you all this time for all these employees and all this money doing that. Nothing ever goes as planned by Styx plays as a constant anthem. Right. All right, let's see what this one's doing here. Okay, good. We actually did get the PHP shell here. Let's look at the exploit planner. Excellent. Obtain a PHP web shell code artifact. Boom. Perfect. That's what we needed. Navigate to the panel, upload PHP, do this. All right. Let's see where it goes from there. So it gets the Diceco artifact, which tells it basically the full path to where that is. We then get browser navigate, and then we get browser upload. And so the ultimate result of that is a failure, but that's expected failure. Boom, PHP is not allowed. Then we get, let's look at the revisor step. Let's go through here. Scroll down. There we go. Try bypassing the PHP file upload restriction by changing the file extension to php.jpg. Boom. So then we call the file rename, and then we try the upload here. Okay, we're getting places. We are getting places. Things are happening. Let's go see. Actually, let's back this up one. What was the result of all this work? Success. PHP JPEG extension uploaded. So if we come to the revisor, it should say that was validated. Boom. Now, did we crash? Yep, we crashed bigger than the Titanic. Damn it, we hit a rate limit error here. Let me go check something real quick. So we come back up here. So here was our rate limit error. So prior to this, we should have seen some stuff happening. Making LLM call right there. Are we not catching this rate limit error? Why not? The LLM helpers here should have been catching this, right? Because basically what we did is we put in, for exceptions, we should be able to put in a tuple for API status error and rate limit error. And that should be the correct error that we got. Let's see what the actual exception was for this. Yeah, rate limit error. And I'm pretty sure that's the one we imported. We had an anthropic.rate_limit error. Yep, so we import the API status error and the rate limit error. Okay. Let me check something in this retry library here. Eventually, I do need to go put a logger in here so we could keep an eye on this, because then it would tell us, hey, if we had a logger, we could say, oh, by the way, we had an exception, so we're going to retry this. There's one way we can kind of get an idea on this, and we can see if it tried. Which I don't think this is the case, because look at this. It only took 2 seconds to make this API call. This language model call here, right? So we have all of our input, no output. Dang it. You pissed it. Try hack me will sometimes rate limit you so you don't DDoS the server. But that wasn't the error that we got here, I don't believe. Let me see what the navigate was. And plus, it's not like if they were going to rate limit me, I would have expected it to happen on GoBuster, not necessarily on trying to click an upload modal, right? Actually, look at this. It tried to hit dicewebshell.php in here. So what did we do after this? Let's walk through this entire chain real fast here. So what happens is we get the Diceco web shell, we navigate to the panel, we hit the browser upload, the upload fails because it doesn't accept .php files. Yep. Oh, stop scrolling. My mouse wheel's kind of busted. So then the reviser should come in and insert a prepended task to rename this. Try bypassing the PHP file upload restriction by using php.jpg. Perfect. So then we do a rename. Rename works. And then we come through and we try another upload. It should say that this works. So the upload works at this point. And then what does the reviser tell us after the upload here? It's validated. Good. So then the next step in the chain is I need to access the PHP web shell that was successfully uploaded with the .php JPEG extension to the uploads directory. So what it does is it calls browser agent. And then when it calls the browser agent, it tries to navigate to Diceco web shell php.jpg. And then what's the response back from this tool call? Like, how does it actually handle this? Let's see. So, oh, this is great. The server appears to be interpreting the file as an image due to the JPEG extension. Let me try accessing the PHP web shell directly without the JPEG. Okay. So, let me actually look at this real quick. So we navigate to it, because we can actually go pull this up in the browser. Let's do that real fast. What does it look like when we access this from our own browser? It looks like nothing, because I didn't copy the H. Okay, great. This is perfect. So it did try to render it as an image. That's going to fail. Excellent. So then the problem here is it tried to hit it normally and then it failed. So okay, so part of this rate limit error, let me go double check. I believe I know what's happening with this. Let's see, Anthropic rate limit error Python. Let's see, there was a bug, but this is from 2024. Let's see. Let's just try the general rate limit error from the API. Yeah, you're all good, Gumby. All ideas are helpful. Unless the idea is like put bananas on my feet, in which case I'm going to tell you you're dumb. Thank you, honey. Sock brought me my water because she knows I'm probably dehydrated from being out there. Because we were out at the track for like...
Your voice sounds worse.
Does it? Does my voice sound hoarse, guys? Just call me dizzy. So you're hitting the input tokens per minute, and so you should wait until after the retry to reduce the input context. So very true. What I'm thinking here, Dizzy, is the problem is in the browser agent itself, the context is not optimized. It's very wide and it has great tracks of length. However, so there's one thing we could do, which is we could go optimize that, which actually means completely reworking the browser agent. I was hoping this would work without doing that. We should have a catch in here. Right here. So in our LLM helpers, what we've got... You know what's funny? So the reason why the mouse wheel's all jacked up is because I was playing too much Darktide, and if you scroll the mouse wheel, your character changes weapons really fast and there's no limit to it. So it was just to spam the sound of changing weapons, and now my mouse wheel just wants to continuously scroll. It's annoying. I feel dumb for that. But anyway, what should happen is we should have two exceptions here that should be caught for the retry filter, which is API status error and rate limit. So either maybe I have this wrong here, because this should back it off up to a minute. I'm going to back this. I'm going to try this. So we're going to give it 4 retries at 20 seconds each. So it should be impossible to have hit that 60-second window, right? Let's see. I'm maxing out the per token limit, right? Get dizzy. So in this case, we should be completely backing off more than 1 minute, right? So 4 retries with a 20-second delay. The thing that makes me think that for some reason we're not catching the rate limit error here is because in the stack flow here, if we come down here, this one, it basically said 2 seconds, bam, instantly failed. This should have, if we were getting some kind of an error, it should have backed off and said that this prompt was taking longer to run, right? All right, so maybe I need to go double check the retry setup here. Let's go. Python retry decorator. So we send it our exception here, but if I remember correctly, you should be able to send it a tuple of exceptions. Yeah, right here. Like in this case, it's value error, type error. We just wrap it as a tuple, and it should have worked. However, there's some kind of a mismatch here. The rate limit error that Anthropic is sending back isn't being caught for some reason. We haven't actually been hitting the API status errors in here. Strange. And the only reason why I put that in is because I was hoping I wouldn't have to go re-architect the entire browser agent, because right now we're using what is essentially a pre-built agent to do it. Hey Dizzy, thanks for coming online, man. Welcome in. I hope you're having an absolutely amazing Sunday. I had a really good day today. I need a Monty Python reference jar to go in the swear jar. If I remember, Ken, I'll make one for you. Let's see here. Let's see what we do with this. Man, it was doing so good, too. The only way we could actually... if this doesn't work and for some reason it's not catching the rate limit error, we're just going to have to bite the bullet and go re-architect the browser agent. Let me go try something real fast here. I've been trying all night to get the iPad to come on so I can diagram stuff, and for some reason it is just not having a good time. Yeah, it's still not working. It's very weird. Most of the time it works well, but occasionally it just will not connect, so I can't mirror it. All right, let's see what we get here. So we get an artifact, we get a navigate, we get an upload attempt, we get a file rename. What are we renaming it to? So it's going to try PHP JPEG again, and then for some reason it tries to do a get. And then what's the next, what was the step it was trying here? What was the instruction we gave it? What's this task? Let's see. Stop scrolling. There you go. Access the upload web shell at uploads. That is not accurate. Hold on. Let me see if it errored out real fast here. Let's see. And it's still trying. It's doing its damnedest. So hold on, what did we try to upload here? When we uploaded this, upload was rejected. So for some reason it tries to rename the file and then go to the next one here and do a get request. Hold on, let's go take a look at the state table real fast here. Collapse, 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 collapse. Let's see. So we had it get a PHP web shell, navigate to the panel, upload the shell, access the shell. Hold on, so how come the rename here didn't happen? See, like this, there should have been a new step added in here. Hold on, so let's go look at the reviser. What did it say? So we told us to upload the PHP. So this is where it screwed up, right? If it did fail it, that's fine. But then the revision was upload it with the .php JPEG extension through here. And then once it did the rename, it validated that here. See that? So it skipped over the upload step when it did this. All right, are you still running? Do I need to kill you? I think I overloaded the web interface. No. Okay, you just stop. Stop. Do nothing. Because you have failed. It's just trying to do an HTTP GET over and over and over again. Let's see. All right, so back to the prompt engineering part. Let's go take a look here. So where's our reviser? There's our prompt template. Exploit step status. There we go. All right, so what did we tell it here? Let's scoot this over. So tasks that require artifacts should be the file's full path, the file system path. So we've got that. If the task is validated, leave the revision field blank. If the task has failed, provide a revised task that corrects for the error or blockage. Each task should be a single instruction. If new steps are needed, specify the new step is true. Okay, so let's change this a bit. Let's re-architect this just a wee bit. Actually, we're just going to add in new steps to it. what we're going to tell it is... Consider the nature of the blockage. If the correction step needs to occur before the current task, I can't spell. Still can't spell. Is it 2 R's? What does occur? Hold on. I thought I spelled it that way. Anyway, needs to so if the current step needs to occur before the current task, set what's the output for this? I think we said set new step as true. There we go. Let's actually go change this real quick. Let's say revised instructions should be a single task. And then actually what we can do is we can give this an example here. So we can say, good example, rename the, I'll give it an example. Rename the web shell with a .php let's say new extension. Now, hold on. I don't want to give it like an exact answer and just tell it, hey, this is the solution for updating this. Let's see. We'll do this. Rename the file to bypass upload restrictions. There we go. I try to keep it generic enough so we don't just give the entire plot away. So we'll say to upload bypass upload restrictions, and then we'll say bad example. Give it a bad example here. Go to the upload form and rename the file and upload the new file. There you go. So compound instructions should be a single task, and we'll say that. Actually, we'll say that never compound instructions. I can't type. There we go. Never compound instructions. Instructions. There we go. So we'll do it like that. Take that out. Save us a couple of shekels on the tokens. There we go. So good example. Rename the file to bypass upload restrictions. Go to the upload form, rename. So basically we're telling it do not do compound restriction. Don't do compound instructions. Okay. Now let's go try this. So this one failed. That's okay. We expected it to. All right. 800th time is a charm. Hey, Noom, what's up, man? There we go. All right. Come on, little exploit agent. You can do it. I have faith in you. I really wish I could see this in more or less real time, but the way it does this, it just... Maybe, can I watch the trace in real time? Will this help out better? Does this update in somewhat real time? Let's see. So we got a web shell. We navigated to the page. Okay, this is updating a little bit faster now. Cool. And then it's going to try and do the upload because it's browsing for the file. Hey, Peaches. Okay, let me just bring this over because I'm not going to view this data probably over here. Doing the OSEP lab right now. Oh, dude. I feel for you, man. So my mom was like, hey, when are you going to have some free time? Because we got some stuff we need to work on. I was like, I'm not going to have free time until December. I got a blog post. I got a vulnerable web app to write. And then since I've been trying to work on cutting a YouTube video for every Saturday, sometimes on those Saturdays or those Friday nights, I'm up till 5 in the morning doing the editing and getting it ready to post. So I'm still learning the editing process, and I will never, ever badmouth an editor ever again. Hey, Ghost, what's up, man? This right here is not a code editor directly. It's kind of a telemetry screen built into LangGraph. This is called the LangGraph Studio up here. And so there's a couple different pieces to it. There's also LangSmith, where you can actually see these traces happening. All the code's actually being written in Python over here in PyCharm. But as we execute this and we want to get tracking data, we get all of that from this layer right here. All right. So we hit that text error again. Man. All right. I tell you what, I got to run to the bathroom, guys. I'll be right back. Hey guys, I'm back. Also had to let Peaches out. She was very adamant about going to the potty. Why is the cybertext hitting India? No! Dude, they go all over the place. All over. Every minute of every day. Alright, let's see here. So what did we do here? So it pulls the DiceCo artifact, navigates to the panel page, probably. Yep, navigates to panel, attempts to do the upload. Let's see.
Caution. A virus has been detected.
Hey!
_tennis virus detected in the network.
The hit tennis virus. What's up, man? That's all right. We send the legally distinct cookie monsters to slow down the hat tennis virus. What's up, dude? I guess this is payback for me raiding you the last 2 nights. Always getting you before, like, right before dinner happens. Dude, we're making good progress on the HackBot though. We were having an issue where, as we hop through all the different nodes in the agent, if it hits more than basically 25 node hops, it thinks it's in a loop and it calls a recursion error. So we managed to up that limit so it can do it. It's getting so close. I think I've hit a wall though, where I have to go re-architect the web browser agent that it's using. Ugh. Fisherman Guy Bro loves that stuff. Yeah, and I haven't seen him in a little bit. I hope he's doing all right. But yeah, so we're getting really close. Actually, we're analyzing the steps it's taking right now. Because what it's supposed to do is get a PHP web shell from the artifact library, send that up to the website server, get an error, and then craft a bypass from that error, and then basically do some more checks on it. So it looks like it did that. What file did it rename it to? So it tries to rename it to PHTML. That's fine. Comes through and does the upload. And what is the upload? It looks like it was successful, probably. Oh, no, let's go over here. This will tell us where we're doing it. Hey, Fisher, good, man. Excellent, I'm glad to hear that. Yeah, so even here, we get the success. It accepts the PHTML extension. And so actually, let's go look at something real quick. Where is... So this should be uploaded to the uploads directory. Let's see if we can pull it up over here in the web browser real fast. Let's see. So PHTML. It does pull it up, but it doesn't look like it's taking it. I have to remember, though. How did I structure that? I don't remember what dice code takes. I think it just takes a command URL parameter. I gotta go check robo pages real quick. Let's see. Where's our pages? Cybersecurity, offensive, web shells, PHP. Let me see. So this is for us sending a command to the web shell. So the string is... Yeah, CMD. So let's go... I don't think it's going to work, but let's go give it a shot real quick. So we'll do CMD equals who am I? I take it back. I thought you had to rename it to exactly a .php5. Apparently PHTML will work also. Ooh. Now let's see. Okay, hold on. How far did it get with this? So it gets that going. The reviser should come back and say that... What do you mean it failed? What do you mean it failed? It absolutely worked. The browser agent is telling us it worked. Reviser, what are you doing? You're trying my patience, you damn AI. It literally says right here, success, it worked. All right, we... Where did it hit this right here? Success, it worked. We should be able to hit this from diceco webshell.phtml. Perfect. What's the error that it finally ended up throwing at us? It threw the damn text error at us again. Is channel members hacking each other a thing that happens, or is it just a meme in the warning? A little bit of both. So that was actually, for anybody who doesn't remember whenever you came into the chat, that's a rule that actually originated from the Dallas Hackers Association, which is a group that I attend quite frequently. And that rule was put in place because we had people doing stuff, right? So basically, it was a little bit of a meme, also a little bit serious. Don't mess with each other. Be excellent to each other. The biggest thing that actually happened, so the reason why the don't hack Twitch or YouTube rule is in there is because the first rule of DHA was don't hack the venue, because we actually had that happen one year. And we used to meet at this bar, and they had unencrypted open Wi-Fi, and somebody thought they were going to be real slick and go through and do an art poisoning attack. And I would diagram this for you, except the iPad is out of commission tonight. And what happens when you do an art poisoning attack is basically you're trying to funnel all of the network's traffic through you. And that can work. However, it's also really easy to screw up. So for example, if you have not enabled IP forwarding in your kernel to turn on that module, then it's just the packets will come to you and you can see them in Wireshark, but they don't go anywhere. The conversation never essentially happens. So that's exactly what happened, and the person ended up basically performing a giant denial of service attack on the wireless. Needless to say, we were not asked to come back to that bar ever again. It was pretty much a layer 2 denial of service. Yes, sir, it was. Yes, Smitty, you are absolutely correct. Oh, guys, this is blue balling me so bad because it's right there. It is right freaking there. I didn't think that PHTML option would work on this. I'll actually want to go do something real quick. Let's go do an LS real fast. So that's really interesting. LS tag. Let me see if that'll %20 it. What's our present working directory in here? Interesting. So we're in uploads. However, if we do an LSLA in here, it's only showing up as webshell.php5. So here's what I want it to do. I want to see if I can rm webshell.php5. Okay, it returns it, and now if we try to run this again, it should just absolutely fail on us. So if we do an ls, why do we have shell.phtml now? Okay, rm shell.phtml. What is going on with this thing? Is it only returning like the first one in here? Look at that. Okay, hold on. We're gonna have it nuke itself. And now, if we try to do like an ls, it should just fail. Okay, cool. We don't have that in there anymore. You know what I should have just done? I should have just backed up to the uploads directory. So there's this one that's left in there, that's fine. But the PHTML extension was working on this, so cool. However, the browser agent has to be fixed, unfortunately. The React agent is being too chunky. It's being too stupid. So let's go fix it up. So I'm going to bring this over here. So here's our agents.py. I need to double check browser also. Let's see. Where's browser.py? Actually, I take that back, because I'm pretty sure we do the create React agent over here. Let's do find. I guess not. I guess it actually does happen in browser.py. Okay. There's no way. This has to happen over here. I'm trying to remember how I wrote the code for this. Let's see. Yeah, there's the browser right there. Okay. So it starts, it goes to browser. Browser is our browser wrapper. Let's see. So if the state is an exploit task, what do we do here? We have to invoke this somewhere. I'm trying to remember. Where did we put that? There it is. Agent execute task. All right, so where does agent actually get declared? Oh, okay. So that's from our persistent browser agent, which does get imported from browser.py. Okay. That's this class right here. Let me see. I'm trying to remember how this is actually one of the very few pieces of code that was AI written. Everything else, except for one other piece, I wrote. But this was one that was fairly complex, and I was fighting with it for about 4 months before I finally acquiesced and was testing with it and letting it do its thing. I think this one was actually written by Claude. Go figure. So where do we instantiate this? I gotta remember. Where's our browser agent? Where did I have that? Let's see. There we go. So we do agent. That's going to be our persistent browser agent. And then if we're going to do exploit stuff, I need to put a to-do in here. To-do fix to mirror exploit test. There we go. Because we're making modifications over here because we're currently only using it in the exploit context, but that's okay. Let me think about this. So we get our task, we get our task step, we do an exploit task, we do a browser task, we do a result. And what we do is we do agent execute task when we do this. And so our execute task, I believe, is wherever we actually create the React agent. Let's see. There's our response state. Hold on. There we go. This is it right here. So this is not an actual state table. This was a weird artifact of the AI. So I probably should go through and rewrite a bunch of this code as well. But I'm going to work on this for now. So for the agent, where does state agent actually get set up? Yeah, here it is. This is our create React agent right there. So that's where we'd have to go through and actually architect all this crap out and fix it up. All right, let me think about this. So if we're going to be making a React agent, what we've got is we have reasoning and action in here. Let's go look at something real quick. That's our pre-built agent. That's the one we're using right now. What is this? Oh, that's hyper browser. Actually, even though they're using a hosted solution, maybe we can actually look and see what they're doing with the agentic setup here. Let's see. So for the tools, they call this function to get it. We have result, which is tool run task go to hacker news and summarize top 5 posts. Okay, not exactly what we want. I was trying to see if it had anything for like an agent request in here. Tifu. What's up, man? Hope you're having a fantastic Sunday. Thank you for coming online. Welcome in. All right. Why, hello there. Sorry, that was my best Ewan McGregor impersonation, and it was not that good. Hey, Stratum, what's going on? Let's crack a lackin'. All right. Let's go take a look at something real quick here. So for this React agent, what we're kind of seeing is we want to clean this up a bit. So if we come down to the browser agent, if we come into here and we kind of look at like what's the output from this, right? Let me think. Should continue basically just takes in 47 things in here, right? And it's just working on whatever this message history is, right? So we're flooding it with all sorts of information. So what are you doing? Are you hacking an AI agent? Kind of. We're actually creating an AI agent to go play capture the flag games. So something like try hack me or hack the box. And it's actually working out fairly decently. Hold on. Good. Add an hour. I forgot about that. You just reminded me that I needed to update the list here. And it's working pretty well. The problem is we were using a built-in agent from LangGraph, which is the framework we're using to build all this in. And the React agent it works, but it's very inefficient. So we're hitting some roadblocks with it whenever it's going through and doing things. So instead, what I think we're going to do here is we're going to come re-architect this. So instead of using the React agent, we're actually going to go have it build a browser graph in here. I think that's what we're going to do. Kind of like Expo? Not exactly. So Expo is largely focused on web stuff, right? Because that's where most of that stuff comes from on like HackerOne. And Expo has some really weird things around it. It was like #1 in reputation, but also they have humans in the loop, so it's overhyped in a lot of ways. It's interesting what they're doing, don't get me wrong, but as is typical with a lot of AI stuff, they're overhyping it. Literally, if you go look at HackBot over on GitHub, right? Let's see. GitHub. Blaise. Come on. Oh, sorry, because I called it Hack the Bot. I'm gonna rename this eventually. But I straight up tell you, this is a fun project. That's its job. This is exactly what it's supposed to do. I need to go put the warning back in here that basically says, don't trust any of this code. It lies. Yeah, I used to have a warning up here that said, don't trust any of this code, it lies to you. Because it absolutely does. Right now, it's very much like a work in progress. But Expo has like a big old team behind it too. They've got like 25 data scientists and information security specialists that are constantly like massaging and playing with it. This is just a small thing that I'm building to, one, learn how to program better. I'm a professional penetration tester, so I don't get to build things very often. So this is a chance to go build something and work on those skills. And the other thing is learning how AI agents kind of work and where some of the pitfalls might be. Because some of my customers are implementing them and I get called up to go do penetration tests on them. So it's a multifaceted event. Those are just like the two biggies. There's actually several knock-on goals that are going to happen as part of that. Oh, thanks, man. It's a bit behind right now. I'm going to warn you. I haven't pushed a code update in 3 months. And that's because I added a new major feature and I was trying to roll that out with the exploitation agent update to it. So right now it's very, very dumb. It's very dumb. right now, this is the entire workflow, basically, and this is not really doing anything. This is not really doing much. Stinger's not really doing anything. All the magic's kind of happening in these 3 agents right here. Stinger's eventually going to be the supervisor, but we've got a 4th one we need to add over here for post-exploitation. That's going to take a while to run. And then eventually, after that one, then we'll come back and work on Stinger, so Stinger can actually start creating its own task list and analyzing the target and figuring out how to do the exploit itself. So that's the next kind of goal after the post-exploitation agent. So recon and enumeration, they're all data gathering. The exploitation agent's job is to get something on the system that can get code execution with just one code, right? One command. And then the post-exploitation agent's job will be to upgrade that to a C2 agent, and then it'll also have the job of handling interactions for privilege escalation in there. Those are going to be its 2 big jobs. So a lot of fun, but the post-exploitation agent is going to take a while because we're going to basically create a full integration over to Mythic C2, which is going to be a beast. So when I get to that point, I'll have Cody, who's the guy who wrote Mythic C2. He said he would come back onto the live stream and we kind of spitball it and work through it. He's a super smart guy. Very, very nice. Disclaimer, the AI may provide answers that are 50% genius, 50% nonsense, and 100% confident. Yeah, exactly. Awesome project idea. Oh, thanks, man. Dude, yeah, so I'm working on this every weekend, basically just on Saturdays and Sundays. Again, very different from Expo, who has a full-time staff trying to do that. But also Wednesday nights I'll come to him and we'll do hacker news. We'll have a good time with that. But yeah, that's basically what I do with it. I used to stream more often, but then I had a lot of life events happen in the last year that really just threw everything into chaos. So this is like the minimum streaming schedule I could kind of commit to. Plus, I do have some stuff that I need to work on off stream, so. I guess it's hard to keep away from the human in the loop, so because AI is very capable of hallucinating because of the confidence. Yeah. Eventually, there will be a human in the loop in this one, but it's meant to be a fallback. So, for example, let's say we're doing like an exploit in the exploitation agent, and it tries like 3 or 4 different exploits. Eventually, if it gets stuck, it can bubble that up to Stinger, or to the user input. And then user input, this initializer will go away. And then user input would then come down to Stinger, and it would process how to update that interaction. Oh, I see the problem. Removes code. That didn't work. Now I see the actual problem. Puts the code back in. Dude, that's exactly what I did. I do that crap all the time. I am by no means a good developer in any way, shape, or form. This is just me practicing with it. Modern Shogun. What's up, man? I love that dial-up sound. Thank you for coming online. Welcome in, man. Speaking of Shogun, so there's a movie theater near my house that I think next month is going to be showing Barry Gordy's The Last Dragon. And if you've never seen that movie, it's like a really cheesy 80s movie, and I absolutely love it. It's one of my all-time favorite movies. So me and my brothers, who also love it, we're gonna go see it in the theater, which we never had the chance to do. Sorry, I hope I didn't turn the mic back on there before I finished coughing. All right, let's see. So this has to go away. This is criminally inefficient. So, how do we want to do this? All right. Let's put a to-do in here. To-do. Make an actual useful agent. There's something else we can also do with this. Let me look at the trace real fast. So whenever we make this browser call, right, what do we get? We get to close, resize, we get console messages. we should probably go filter this tool list out here. So what we're doing is we're just loading everything from the MCP server. I think instead what we should do is take this and pull out a subset of these, right? Let's make a list of this real quick. Hang on. Hold on. Let me pop into OPSEC mode real fast. Okay, good. Nothing. I never know what I've got open in VS Code, so I didn't want to go flooding this thing. Let me bring this up here, actually. Because every time we send this, we're basically sending all of these prototypes for all these functions over to the language model. So I don't think we need like a tab new in here. Let's see. What does the select option do? Select an option from a dropdown. We're going to need that. So let's grab. What I'm doing is I'm just making a list of these over in a text document. We want browser click. We absolutely need that. Let's see. We might need snapshot. Capture accessibility snapshots of the current page. Yeah, let's go ahead and grab that too. Let's see. What else do we want to do here? So browser closed, not going to need that. We shouldn't need to resize it. We may want to handle console messages. I'll grab that as a maybe. What about handle dialogue? Handle a dialogue. Okay, yeah, gee, thanks, guy. I think actually we will need that. I think that's like maybe for text fields. Evaluate JavaScript expression on the page or an element. I don't think we're going to need that. Let's grab this browser file upload. We are absolutely going to need that. Let's see, browser install we're not going to need. Browser press key. Yeah, we'll want that just in case it needs to send a keyboard stroke. Let's see, browser type. Type into an editable element, yeah. I'm trying to see just what's the bare minimum that we need. We do need a navigate in here. Navigate back forward. I don't think we need that. What's this network request? Returns all network requests. It's loading the page. Probably don't need that. Browser takes screenshot. I don't know. I don't think we're going to need that. I don't think we're going to need the snapshot either. We already grabbed the snapshot. Okay. So from this long list, we've got maybe 9 of these that we absolutely need. So let's do that first. Let's go filter the tools that are coming back from the MCP server. So we're not going to present all of them to the language model. So let's start with that. Where do we get our tools at? Where is this? Oh, I don't need that. Ooh, let me close that up. So I'm going to put a break line here just so I remember that. Have you tried Grok code yet? I have not, actually, Smitty. So for the most part, everything in here is completely human written. There's only 2 places in this code base that I used an AI to help out. And it was only after I struggled with it for several hours before I kind of acquiesced to it. But I'm of the opinion that AI should largely be restricted for most people to a learning capacity until they gain very good subject matter expertise. And so it should be a bit of a helper and maybe a little bit of a teacher, but even that's suspect because it can hallucinate very poorly, right? And there should be a lot of experimentation and hands-on work and people building out their skill set. And then you can potentially layer on AI to help augment your workflow or the kind of work you're doing. So several people in my family are teachers. I see people on TikTok who are teachers complaining all the time about students not knowing anything because they're just outsourcing all of their critical thinking capacities to some LLM system, right? So that was not what I wanted to happen here. That would defeat several of the goals. So I haven't, to make it a very long-winded thing. Hey, Beanbag, thanks for the raid, man. To make it a very long-winded answer, no, I haven't tried Grok code yet. I actually did use Grok to help create one portion in here, which is, it's in here utils. We're using a tooling server called RoboPages. This was not written by Grok. I wrote this. However, the structure for it was written by Grok. I told it what the requirements are. It had a good idea. The code was not usable in any way. I went and basically implemented it correctly, but it was from the ideas that Grok had spit out. So I was testing that out just because I had it on Twitter. And for the most part, I'm kind of using Anthropic now. The benchmarks are pretty crazy for it. Yeah. Attention span goes burr. I know, right? I try to stay off the short videos too much because, yeah, they just wreck my attention span. Let's see here. Let me close this up. I was just showing that one. Okay, so here's our tools, right? So we load our MCP tools. What is this actually returning in here? This is returning, well, it's returning a coroutine, but load all available MCP tools and convert them to LangChain tools. All right, so these are LangChain tools. Let me see if there's an efficient way to do this. Let's see. Filter LangChain tools array. Actually, what we can do is we can just say LangChain tools and go look at what the tool structure is in here. No, that's not what I want. I want the actual prototype. Oh, interesting. They actually have tools for, like, SQL. Interesting. All right, these are not the tools I want. These are not the droids I am looking for. LangChain tool Python. Let me look at this. Not what I was looking for. That's for Python REPL. How to create tools. Let me look at this real quick. Star Wars reference. Dude, I love Star Wars. I actually cannot wait to go watch it with Agent Zero and Honey Badger. I had Honey Badger freaking had me rolling the other day. So Honey Badger's my 3-year-old son, right? And we've been watching My Hero Academia with him. And he's getting all into it. The boys have little mock battles and stuff. And he's got a whole bag of like Mega Blocks, right? The giant Legos. And I hear from the other room, I'm in the office, I'm working, and from the other room, I hear Honey Badger go, 100% smash! Boom! And I hear this Mega Block explosion from the living room. I could not stop laughing. Cracked me up. Him and my older son, Agent Zero, they're so funny. The stuff they come up with. Sometimes you just gotta full send. Exactly. And Honey Badger's all about that full send. My father-in-law is like, hey, we should start putting him on my son's old ATV, the low power one. I was like, no. He's got to learn how to follow instructions first, because he'll just full send it. I need him to know how to chill. Boy has zero chill. All right, I think, let's see. I need the actual tool structure. I don't need the actual... Let's see, this is creating a runnable. That's not what I need. I don't need a runnable interface. What I need is the actual tool API call in here. Let me think about this. I think the type for this would be... I think it's LangChain tool. Let me see, because the load MCP tools is eventually going to return a list of LangChain tools. Yeah. Let's see, tool node. That's not what I need. See if I can find. I'm assuming if IntelliSense will tell me the type here. Oh wait, hold on. Actually, I know where I can find that type. Hang on, because this is exactly what we did in the LangChain Robo Helper here. So a RoboPages tool is like this, and then what we do is we return. Actually, I take it back. That's not what we need. Where is it? So we get the tools and then we create the tools, and what we do is we say actually, yeah, this is where we actually go create this here. Hold on one sec. Let me see here. Base tool. There we go. That's right, because our RoboPages tool expands base tools. So this should be a list of base tools in here. Let me go to, I think I can just do Control B. There we go. Let's see. So what do we do for the init here? Well, this is for the init subclass. So we just have a name description. So I believe what we could do is we could try this out real fast. I'm going to take this list of tools. Let's bring this over to browser.py. Let's call this our tool filter. And what I'm going to do is I'm going to make this a list of all these tools, and we're going to have to go clean up the list here. Let's see. I'm going to do this the hard way. Let's see. Drop these in because I don't know what the keyboard shortcut is for this. Okay. Oh, I got to do this one too. There we go. Actually, I'm going to take this back. Hold on. Because I like the way this was kind of set up here. Let's clean this up. And we'll just tab these over. A little bit more. There we go. Excellent. So now what we have is we've got a tool filter object in here. I'm going to take this out, and what we can do is we're going to get this list of tools here. I'm going to call this MCP tools. And we're going to say tools equals. I can't remember how to do that. I know there's a way to do this. Let me see. Python or assignment operation. I believe this is where we can do this. Let's see if this has an idea here. Because I've been meaning to actually like understand how this part actually works here. Because if you need it to actually like iterate over something, you can use a for loop as a one-liner. But it's not something I fully get every time I do it. That's not it. Let's see. Assign from for loop. I could just for loop this out. No, that's not what I want. Maybe this is a for loop assignment. This is what I'm trying to get. You see, I'm just trying to find an example of using it, so I can grok it a little bit. These guys are all talking about different stuff in here. Where's Palmer when I need him? Palmer would probably know exactly what I'm talking about. see. That's right, assign it from a one-liner. No, that's not it. Okay, that's basically like a multi-variable assignment. That's all right. There's a variable swap. Conditional assignment. Okay. Hey, poet. Yes, that's exactly what I'm looking for. I know there's a way to do it where you can say, hey, basically, because what I want to do here is say, what we're going to do is we have our tool filter. We're going to go to the tools. I want to pull out the tools into an array that their name matches something in the tool filter here. And I know there's a way to do that. Let's see. Python return list from for loop. Check out array map. That may work. See, this is the usual example, right? Hey, we've got a list here, and we come through and we run this. Let's see. Python. Let's see. Iterator map. Processing iterables without a loop. Okay, this might work then. Let's see. Actually, if we had a filter function, that might work. Anyway, let's see. So for map, we do the function, we do the iterable, and then we just have it back. So map applies the function to each item in the iterable. Okay, so map won't exactly work because what we want is... Yeah, I remember mapping now. That makes sense. However, map isn't exactly what we want. What we want to do is we want to filter an array. Let's see. Oh, here we go. There's a filter option. Boom. Okay. So we could just probably do a lambda function in this and do a filter in here. I wish I could remember where that's done. I remember where I actually saw an example for it. Let's see. Now, it was in the RoboPages example, but it was actually a really big example in here. So this just has to return a true false, right? Okay. So let's try that. So we do filter, we do the function, we do the input array into this. So let's see if we can make that work. Not quite, FOA, because this is just the name of the function. This list here is actually going to be an array of tool objects for LangChain. So we will need something in here. And I think we can just do a lambda function, which I actually have not had to do. Let's see. Python lambda functions. Because what we're going to do is this is just going to be a property of that tool. And so we're going to pull out the name property of it. And then we're going to say, hey, if the name property is in the tool filter, then yes, we want to return this as the array. No, you're all good, man. I welcome all heckles and observations. And often, a lot of times, it's people telling me I misspelled something. So in this case, it was x equal to 5. Let's see. Let me try this real quick. So if we run this, we run 5, then it should be 15 as the return, right? Yeah, okay. So it makes us a nice little lambda function in here. So we just specify the input and we return a true. So all it has to do is just return a true or false in here. So easy enough. So what we'll do is we'll say T, and we'll say T, I believe it's dot name. T.name in tool filter. I believe that would actually work right there. So if we do this lambda function, it should check T against this list right here. So we're going to pass in NTP tools. Right here. I think this would work. And then what we should see is now tools will get passed over to this, and it should work. I kind of want to go do a quick test of it, actually, just to see if that filter is running before this happens. Oh, instead we got a filter? Okay, that was not what I was expecting. Apparently I'm doing the filters wrong. Let me see. Oh, I have to convert that to a list. That's why. Duh. Alright. I forgot about that for filters. There we go. Let's see if that hot loads in. Hey, John, what's up, man? Okay, so it looks like it hot loaded the code. I'm going to do one more quick test of it from the exploitation agent. So let's go to exploit, and we'll let it do a quick run here. Because all we're going to do is we're going to wait for it to hit the browser agent, and then we're going to basically stop it at that point. Because if we see a reduced list of tools being passed over to that agent, we know we can kit it, we can cut it, the filter is working. Convert that to regex? How about no, Bobby? I got 99 problems, and if I add regex into it, I'm probably going to have 103 problems. Okay, cancel. Good. So now what we can do is we can look at this call right here. Excellent. All right, cool. So the filter did work. See this? We have filtered down now instead of that really long list here, right? Look at this. We had all these tools. Each of those tools that we're sending to it is, again, part of the data that we're having the language model process. So it's eating up those cycles. So we've reduced this. That should help with our rate limit problem in here. So we should be good there. Excellent. Okay. At least we know that works well. Excellent. So we've got this all filtered out. Now, what we need to do is go back and clean this up again down here. Hold on. Where was it? Here. Where was the code? Hold on. Oh, it was right next to it. So the problem is this create React agent is not that stupendous. Let me go look at something real quick. LangGraph create agent. Because they actually have an object. There's a create agent, and there's also create React agent in here. And here they're still referencing create React agent. Damn it, Ken. Normally you're trolling me with the dad jokes, which I appreciate. But now when you're trolling me with regex, I'm feeling attacked, personally. I just want you to know that. I feel like this is a personal attack. Let's see. So the React agent, what I want to do is actually I want to see the code in here. Will this actually take me to the function definition? Now, this is just like the API, which is not what I want. I actually want to see the create. Yeah, there's our create React agent. Hold on. Let's back it up. Create React agent on GitHub. Find me the function definition here. Can't help myself. I even ignore my therapist. Let's go find this because I actually want to see, double check something in the create React agent here. All right, here we go. We can prevent the mention of regex if we... We can prevent the mention of regex if we use a look ahead. Damn. No, no looking ahead. Bad. That's bad. Oh, I had to do some really horrendous regex when I was writing an aggressor script for Cobalt Strike, and it was the most god-awful implementation of regex ever. But I think that was mostly an artifact of the programming language, which was Sleep. And the only system I know on the planet Earth that uses the coding language Sleep is Cobalt Strike. Let's see. What I'm trying to find in the create React agent is where it actually returns. Returns a compiled LangChain runnable. Okay. So where's the return from the create React agent, though? I would think it'd be towards the bottom, maybe? Let's see. Okay, here we go. Return workflow compile. So, what I want is all these references to the workflow here. So, add a conditional edge, tool, reroute response, path. Here we go. So here's where the actual workflow is kind of starting. Looks like it actually starts on 51? Damn. Okay, that is absolutely not correct. Hang on. We can scroll down here to the bottom. All right, workflow. Define route tool responses. Okay. So we add a conditional edge to tools, and we are going to either route this to the entry point or the end here. Okay. So if we add a conditional edge, the first thing in it is... I gotta remember what that is. So we add a conditional edge. Let's see. The args are the source and path. That's right. So the source is tools, and we're either going to route tool responses here, or we're going to go to entry point or end. Okay. So where do we actually have entry point in here? Man, they really engineered this sucker. Because essentially what we need, this is not too dissimilar over here to, like, say, the recon agent. So the recon agent here is basically a beefed up version of React, but we've done a lot of context manipulation to it. Why is this all weirdly grayed out here? So this is essentially a React agent, more or less. What it's doing is, and I don't know why it's all grayed out like this. Let me try reloading it. There we go. Bring this over. Okay, so what happens is recon agent comes in and says, hey, I've got something I need to work on. And it says, okay, cool. Well, can we make a tool call? Yeah, make a tool call. We output we format the output. We update any relevant hosts in the host tracker, and then we validate that it was done correctly. Let's see. Create agent. I believe it actually gives us a graph of, like, what it looks like in here. It does not. Where's the diagram for it? Let's see. Yeah, here we go. This is essentially what happens is we send something to the language model. And what's crazy is actually from here, right? We can see that our input is, we just have one human input, right? We don't even have like a system or user prompt in this. That's what's nuts. Same thing over here. when we run this, we have a human input, but there's no system prompt or anything. It's just human input. I have a hard time believing that. Hang on. Let's see, where is it? So the only references to the prompts are like, hey, we're here. Get prompt runnable. And then pipe that to the model. So that's going there. So what are we looking at here? So all we do is we just pass in whatever the prompt is here. So we check if it's a system message or it just does a bunch of different checks on it. So there's a runnable, callable. I need to go do more digging into the runnable structure of LangChain because that's where a lot of the magic happens. That's actually the base execution unit in LangChain. I should have probably looked at it a long time ago. Yeah, see, it's always just grabbing the message in here when it does that. We look at for the should continue here. So the should continue function here, this is how it's actually routing it, right? So if we come look at the drawing here. Here we go. So what we're doing is we're saying, hey, should we go to tools and then return it back to the language model and basically let it run in a loop until it says, hey, I'm done with the task. This is what should happen. And in fact, if we go through and we trace this, right, we can look at it. So what's our, actually, let's look at the, let's use this example here. So this is when we're trying to do the upload and it takes multiple steps, right? So for the chat prompt here, notice how we send a lot of this previous stuff up to it. And it's kind of like choking out the context. So what we can do is we can clean this up, right? We're saying, hey, we're going to upload the PHP web shell. And we don't even need any of this information again because we already kind of had it. Let me think about this. Had to re-architect l'agent. Let's see. So we call this, we make a tool call. It comes back to, oh, actually, let's look at the response back from the, damn it, stupid mouse wheel. There we go. So we come over to the browser file upload. Upload fails because we get this. It takes that output, sends it back over to the language model. So the browser, actually, there it goes. There you go. So then what we get is we tell it to upload. We have a tool. It says upload to it. It says, okay, I apologize. Let me check. Let's first click the choose file. So then basically what we're doing is we're just taking that output, we're piping it back over to the language model, letting it running a loop. Okay. Excellent. We can make this work. We can do this. We have the technology. Where's that should continue function here? So it gives a state. So basically what it does is it looks at the messages in here. All right. Let me try one more thing. in here. Let me go look at something else in the trace real fast, because I'm trying to make sure I'm keeping some of these moving pieces straight in here. So if we come back to the last time we ran Stinger, right? We look at our very first one, which is initializer. Our input, we have a system and a human, right? So we have a system prompt and a human message that goes with it. And then we get the output from basically our seed task that we've got in here. So what we can do is we can take this and we could use this to kind of bootstrap everything to begin with. So this code needs to go away. Let's see, to do make an actual agent. Unfortunately, I was thinking I could maybe reuse this should continue here, but that's not going to work as we do this. Let me think about this here, because we get a lot of stuff back from the browser. So what are the key pieces of information we're going to need? Let's come down to... So basically what it's doing is it's taking everything from the... it's taking all the previous messages and piping them over there. However, we can actually clear that up. We can make it way more efficient once it comes through here. So we have our human input. It's got the tools. So it says, okay, cool, I'll make a tool call. We get the tool information back. And then basically we're sending all of that back to the language model. And then we do this here. Okay. I wish I could show you all the iPad. Well, actually, it doesn't even matter because it looks like my pen died anyway. Let me fix this real quick. Makes me sad when the iPad doesn't work because that's my tool, my diagramming tool. All right. So we can clean this up a bit, basically. We do want this like initial piece of information here. For the browser agent, it's going to get this information to kind of begin with from the human. Because what we're doing is we're selling it, hey, this is kind of what it should know. This is the relevant pieces of information it should have. Let me look at one more thing down here. So when we call the special agent node again, we have all of our previous pieces of information, and then our human says, hey, we're going to do this. And so we're getting a lot of this duplicated in here, right? Just like this. So actually, we may be able to get away with using the messages in here. And look at this, like we have like response metadata and stuff. So this is just ugly as sin. So we need to come up with a little bit of a data structure in here. I'm trying to think like, do I want to basically duplicate a little bit of the structure of the Stinger state and make it like the browser state, where it says, hey, this is the stuff we need to do and the task we're trying to accomplish. There has to be a more efficient way to attack this, where we can kind of keep track of what the browser has done and where it's at and what it needs to do. There's actually another way we could do this. Because what's happening here is you see how we have all these pieces of information that are basically hanging out from the last time. So we've got all this, but then whenever we prompt it again, we're sending it all the information that we've already gotten too. That's almost kind of what it's doing in here, Bobby. Right? And we're sending in all this information to it. So is there a way to track the state from the previous task so it understands the context? And that's pretty much what we're doing here when we call this. Let's see. Because this was our original state, right? So we can look for the human messages in here. That's our first human message. Here's our next human message right here. For some reason, it's... There we go. It's formatting it kind of funky and throws like a JavaScript tag in here. It's just kind of ugly. Yeah, I think what we're going to have to do is we need to give it a system prompt in here that says, hey, by the way, everything that you send should be like very succinct, like minimal response. Don't over chatter. Damn. I was hoping to avoid that. I was hoping the React agent would do it, but it's just swelling up and polluting the context so much. Because we want it to keep track of everything that's going on in the page, right? Everything that's happening in the browser. If we have it keeping track of like what's happening in the browser, because the stuff it returns is stuff like this, right? We tell it to navigate, and it returns these kind of weird chunks, right? Let me see if I can copy this. Let me bring this down here. We don't need this list anymore because we already did it. Let's do a Control H. What we'll do is we're going to search for \n, and we're actually going to replace that with a \n here. So if we run this, this is kind of what we get, right? This is just the prettified version of it. So we ran playwright. Let's see. Job was to navigate to panel. So we're going to await page go to. Console error was, hey, 404 not found for something. That's fine. And we have our page state right here. So really, only thing we need to keep track of, like to know what the state of everything is the tool calls, right? That's going to tell us pretty much everything we need to know. So we want to keep track of all the tool messages as they happen. Okay, I think there's no way around going through and making a custom state table for this guy right here. So let's do a little bit of magic in here. Wee bit of magic, just a wee bit. Let's define let's do this. So what we're going to do is we're going to call this the browser state in here, and it's going to be, see if I can remember how I did this. Yeah, basically like this, a typed dictionary, because that's what LangChain needs, or LangGraph really. And we are going to have a messages state in here, and that's going to be an added annotated list here. And so from this, what we can do is let's see, did we get that from typing annotated? I believe so. That's going to come from LangChain, and that was not what I wanted to do. Where did I go? There we go. That's going to come from LangChain as well. This is not a define. This is a class. Take that back. Class. We're going to define this in here. Let's see. Wait, Oh, it's because I imported the wrong one. It should have been from typing. Why that's in there. So we do want messages in here. We also want to have the... What do I want to have for this? We call it like the browser history? Maybe tool calls? Something. How do I want to track this is what I'm trying to think about. Because we do want this information here. This should be the return from the tool call. So I'm trying to think how we can basically manage the context of this. Because right now the context is completely unmanaged. It's just whatever came back from the language model. So we've got tokens being burned that way. We've also got certain things that are also happening. Yeah, I'm going to leave that one in there, but I'm also going to make a tool calls one in here. And what this is going to be is a list of... I believe it's... what's the message tool call? I've been working on some meta prompt scaffolding, and I ask it to follow the 4 C's: clear, concise, contextual, consistent in the system prompt. And then I ask it to think step by step and explain its reasoning to ensure accuracy. That's probably actually something we're going to have to put into some of the other base system prompts for the agents, the primary agents. Because right now their prompts are basically just being band-aided as we come across issues, right? I think it's tool message. Yeah, that's it. So this is going to be a list of tool messages here. Let's go ahead and import that. Actually, that's not even necessarily correct. Because the tool calls don't look like that. If we come back over here, I mean, the tool calls look like this, right? This is our input. Let me look at something real quick. And so when we finish this up, if we come to the exploit step update, and if we look at our messages history, right, we can kind of tell where it's going to be because it's going to be like one of the last things in the message list. So let's back this up real quick. So last thing we see is AI is, hey, we need to do a couple of things. That's fine. Clear, concise, contextual, consistent. That's what you said. Oh, you said consistent. I knew what you meant though. I felt your vibe there. So actually we're getting all the messages back from it, which is fine. So this message up here actually has the tool call to it. So yeah, as a message comes in, I think what I want to do is I want to split this into 3 sections, right? What I want is I want the text from the AI message. I want a tool call if it's got one. I I cannot think of a better way to do this than just having the messages in here and processing this every time it kind of goes through. I'm trying to think, would it be helpful if we just kept a list of the tool calls and their responses? Tool calls, responses, tool call, response. Does that tell enough of a story? So for example, we tell this to navigate, boom. We tell this, and then we get the response from the browser navigate, right? Let's see. This is actually one of the things that I think really busts up a lot of people is not thinking about how to manage the context efficiently. I even tried to take a shortcut on this one using the create react agent. The problem is it only works on everything going on in the messages key. So all right, so we are gonna need to make a system prompt for this. I wonder if Dispy or Baml would help with this. I'm actually not familiar with those, Bobby. Declared a framework for building modular AI software. Oh, okay. I think I have actually come across that. Let me see. Baml. Would Baml for LangGraph work? So this is an agent. Let me look at this example here. This was something that someone put up on GitHub that's an example using Baml and LangGraph here. Wisdom or philosophy, let's see. Hackmatica is a deep research and conversational agent designed to answer questions on various topics, leveraging web search and external tools and large language models. Huh. Okay, let me go look at this. I'm just curious. So they've got everything in agents.py. Let me see what they're doing here. So they have an agent state, which is a question, clarification, subqueries, plan, raw results, relevant results, answers, critiques, attempt count. Interesting. Interesting that they're using base model for this instead of a typed dictionary from Pydantic. What if there's a reason for that? Why they're using the Pydantic base model instead of just using a typed dictionary? Because I wonder if there's any benefit to that. Let's see. So here's the graph builder. I'm curious about this. So it starts on 206. Let me see what they're doing here. How are they building this? So they add all the nodes. Ugh, I hate this form. Adding the nodes and then adding the edges. I prefer the way that I do it, and I know it might not seem. It makes most sense to me where we add edge node, because when you read something like this, right? How are you reading this? You might start with a node, right? But it's node, edge, and if it's a conditional edge, it gets a little bit funny in here, but I wonder where they're. Let me look at this though, because I'm wondering where they're using Baml in here. Try to do it purely in here. Let's see. The first language for building agents. TypeScript made JavaScript 10 times more flexible. Baml makes your AI pipeline more reliable. So what is the kicker with BAML, Bobby? Is this like a web-hosted system for building your stuff? Or is it actually like a framework in here? No, I mean, you download it and run it. Help mapping unstructured data to structured data fields very explicitly as functions. Okay. Got it. Let me see here. All right, I'll have to think about that. So fortunately, we're kind of out of time for tonight. Let's see. Let's put another to do in here. Make a state table to track the flow from the browser. Okay, so what we'll do is we'll make a state table in here to kind of track what's happening. I'll think about BAML. I don't know sure if I want to bring in another framework right now, but I think what we're going to do next weekend is we'll get the state table kind of crafted. We'll actually build out the agent structure here and get it all set up so we can have a nice, clean interaction while everything's happening. So rather than having this kind of weird, long conversational thing happening, right, where we just got conversation after conversation, we basically build up a context and then send that through to it. And we could even do that with the prompt. Basically, in the prompt, we can say, you're going to be presented data in this form of a task to, let's say, something to do, and then how it went, more or less. And we could basically have a log that we can send to it. So, and then the benefit to this is, I believe we'll be able to execute this and not have to worry so much about the state table. We'll see if we have the exact same problem. Unfortunately, that is where I've got to wrap it up for tonight. Let's see. Oh, good. Slyborg is online. I should raid the Primogen. You know what? Since Slyborg's playing Minecraft, why not? Let's go raid Primogen. Get it over with. All right, y'all. So we hit an order stumbling block, but you know what? Those are just more opportunities to learn. We can do this. We can kill it. We can kick it. Let's see. Let me go set up the raid real quick. Is he even online? I think I just spelled it wrong. Yeah, there we go. Yeah, we'll go right over to him. Boop. All right, y'all. Stumbling blocks, but that's okay. They're just learning opportunities. We can do this. Everyone have a fantastic week coming up. Tomorrow is, for myself included, is crushing it mode. I've got a blog post I've got to get drafted this week so I can get it through QA and get it put up. Hopefully, we'll make those targets. So, everyone, next week. Oh, thanks, Gumby. Yeah, I just finally saw it. So, guys, get ready. Tomorrow is crushing it mode. Get out there.
Sound off like you got a pair.
Gumby! So full of crap. But I appreciate you, man. Yeah, let's crush it. No excuses. Rule 76. Yes, exactly. Rule 76. Crushing it mode. So, that's all I got for you guys tonight. We're going to figure out this browser agent. We're going to make it efficient. We're going to let it do its thing. And I think I know what we're going to go forward with this. So, you guys have a fantastic week. Kick a bunch of ass. And I want y'all to remember one thing, and that is, I love you. Peace.